Hi, this is Ian. There's a problem with using needle gaps or similar shaped electrodes such as wire ends for estimating pulse voltages. The dielectric strength of the air is very dependent on the pulse shape. So this air gap is about 120 millimeters. But what does that mean for voltage? The largest air gap that this pulse generator can spark across is 45 millimeters between these 100 millimeter diameter spheres. There's much less uncertainty with sphere gaps, as the dependency on wave shape is much reduced because of the lack of corona type ionisation ahead of the main discharge. What you see here is a 45 millimeter gap between 100 millimeter diameter spheres in parallel with a 140 millimeter needle gap. Both gaps are firing from time to time, indicating that for this pulse shape the breakdown voltages are similar. Note also that there are occasional breakdowns between the needle gap and one of the spheres. Now a quick check of polarity effects. For this polarity of pulse, the needle to sphere gap is 130 millimeters and it's sparking quite reliably. But for opposite polarity, a gap of 55 millimeters is only just sparking. And this leads me to think that the left hand side is the positive impulse on this generator. Here is a chart that I've put together after doing a bit of a literature search. It has all of the information I could find about breakdown of air gaps between spheres and between needle points. The left hand axis going up the side is the spark gap between the electrodes, and it's millimeters, steps of 10, so it's 10, 20, 30, 40, up to the top of the page 150. Along the bottom of the page is the peak voltage in kV in steps of 25, so it's 25, 50, 75, 100, 125 all the way up to 300. And what you can see is that the needle points require a much lower voltage for a given gap than do the gaps between the spheres. The spheres I've illustrated here are an orange line is 25 millimeter diameter, the yellow line is 50 millimeters diameter spheres, the green line is 100 millimeters, the blue line is 150 millimeters, the purple line is 250 millimeter spheres. And I'm also showing as a dotted line the basic 3 kV per millimeter limit for air, which you will not really be able to exceed with any configuration of electrodes. What it seems to come down to is that it's really the maximum electric field in the gap between the electrodes that really settles when the discharges begin. So with the needle gap, my pulse generator is providing sparks around 140 millimeters, which is here. And if I look at the curve and then follow that down to the voltage axis, it's indicating somewhere around 85 kilovolts. On the other hand, the more reliable measure is the sphere gap, and for the 100 millimeter sphere curve here, the green line, my gap was 45 millimeters, and I follow that to the green line and it comes down to about 115 kilovolt, and I'm happy that the measurement between spheres is more reliable in the case of pulses. So coming to the conclusion, the capability of my pulse generator is probably 115 kilovolts, so I can say 100 kilovolts safely. Thanks very much for watching.